Hello friends, in this video I'd like to solve the following problem from the British Mathematical Olympiad 1981, problem number 5. So we wish to find the smallest possible value of the absolute value of 12 to the mth power minus 5 to the nth power, where m and n are positive integers. So I will give you some hints to try. So it's always good to check what happens at the initial values, because the smallest integer, positive integer, is number 1. So it's good to check what happens at mn equals 1, and then you can make a guess that what happens at mn equals 1, 1 is we attain the smallest, the minimum of our value of our function, and to show that no smaller value is possible, you can try using reductions modulo various numbers. Which numbers? Try. I will not spoil it for you. So give it a go and try it. Okay, so I assume that you tried it. Now, what happens at mn equals 1, 1? So let's see. 12 to the first power minus 5 to the first power is the absolute value of 7, 7. So our minimum, so we can deduce that our minimum over all positive integers is less than or equal 7. The rest of our video will be showing that number 7 is the actual minimum of our function. Okay, how to do it? First of all, let's see. Is it possible that our absolute value of our subtraction of these numbers, can it be equal 6? No, it cannot. Why? Because 12 raised to the power of m is divisible by 6. Maybe not in red, maybe in green, because it is divisible. Is divisible by 6. But 5 to the power n is not divisible by 6. And right hand side, 6 is again divisible by 6, so it's a contradiction, because the number on the left hand side is not divisible by 6, and 6 is divisible by 6. So we get a contradiction. It's not equal to 6. Second question, is it possible that this equals 5? No, it isn't. Why? Because again, similar reasoning. 12 to the power of m is not divisible by 5, but 5 to the power of n is. So the left hand side isn't divisible by 5, and 5 itself is. Okay, what about 4? Again, similar. It cannot be. It cannot be, in fact, 4, 3, 2. It can't be. Again, why? Because 12 to the power of m is divisible by 4, is divisible by 3, is divisible by 2, but 5 to the power of n is not. So the last part, is it possible that can it be equal to 1? In other words, can 12 to the power of m minus 5 to the power of n, can it be equal plus or minus 1? I will show that it can't. Why? Now, it's time for clever reductions. First reduction will be modulo 4. Reduction modulo 4. reduction modulo 4. What happens after this reduction? On the left hand side, 12 to the power of m is congruent to 0 modulo 4, and 5 is congruent to 1. So on the left hand side we have minus 1 is congruent to plus minus 1 modulo 4. And now it's obvious that on the right hand side it must be minus 1, because minus 1 is not congruent to plus 1. So we must have minus 1 on right hand side. Okay, so now we know something. Yes, it's a step forward. So now we know that 12 to the m minus 5 to the n should be equal minus 1. Is it possible? Again, the set answer is no. No, unfortunately no. Why? Let's reduce it modulo 3. Reduction modulo 3. What happens now? After reduction, look, minus 5 is congruent to minus 1 modulo 3. So minus 1 to the power of n is congruent to 1 modulo 3. Now it's pretty easy to see that n must be even. Why? Because it alternates between minus 1 and 1. 1 is congruent to 1, but minus 1 isn't congruent to 1. Okay, so we have another information. So now we can write that 12 to the power of m minus 25 to the power n over 2 equals minus 1. And we know, in fact, that n over 2 is an integer, because n was even. Is it possible? No. Why? A reduction modulo 13. Reduction modulo 13. What happens now? After reduction modulo 13, we have minus 1 to the power of m minus 1 to the power of n over 2 should be congruent to minus 1 modulo 13. But it's not possible. Why? Because on the left hand side, this can be either plus or minus 1, maybe in yellow. I will write it in yellow. This can be plus minus 1. This part is also plus minus 1. So the left hand side, is either 1 plus 1, 2, 1 minus 1, 0, minus 1, minus 1, minus 2, I believe. Yes. And none of these numbers is congruent to minus 1. Modulo 13. So our equation, our hypothesis that our number can be equal to 1, it's simply not true. It cannot be. It cannot be. And finally, can it be equal to 0? It's pretty easy to see that it can't. It can't, because it would imply that 12 to the power of m equals 5 to the power of n. It is only true in integers for m and 0, but 0 is not a positive integer. So all in all, our conclusion, because values of 0, 1, 2, 3, 4, 5, and 6 are not possible, we conclude soundly that the minimum of our function, minimum over all the positive integers mn of 12 to the power of m minus 5 to the power of n equals 7. Lucky number. Lucky. So thank you for watching. I hope that you learned something new and see you next time, hopefully. Goodbye.